Hi, in this video we're going to look into how we can use the java.nio for doing text file operations. So in the other videos I wrote this code that used, first I used the scanner, then I tried showing how to use the buffer reader for writing text files. So in this one I'm going to use something else called the java.nio. And we're also going to use some streams and stuff to make it a bit easier to work with files. So let me show you. So let's try to look at what we've been doing. Let's try to first off try to take the one called print file context, which which right now just prints whatever is in the text file that I have here. So let's look at how that works. So this is the one print file contents. We print this, and then we use filereader, buffer reader in a try catch block, and we just simply print it line by line. So let's try to do that in an easier way. So what we can do in java.nio is we can use some other cool classes for obtaining the same thing. So we'll try here to use some lambdas and stuff like that for making it a bit cooler. So first off, in this case, I want to use the files, which is in the java.nio file package. So the files is actually just a static class, so we can say files, and then we can take lines, and then we can put the path for the file that we want to work with. So we already have the file path here. And also we want to do something with that. So now we get a small error because it's not really like a path like this. It needs to be a specific kind of path. So it uses paths from the java.nio. So what IntelliJ here suggests that we can use this path of file path. And then we need to do something with the files here. So what I'm going to show you is something called a filter. So a filter is something we can use for different kinds of purposes. No, sorry, actually the one I want to start out with for this case is the one called for each. So for each is something that uses functional programming. So what we'll need here is we'll need some kind of description of what to do for each element that's in this list of lines here. So we'll need to define some method that will do something for each line. So what I'm really saying is that for each line that is in this file, do whatever's in here. So what we need to put in here, we need to put what we call a consumer in here, some method that will actually consume each and every iteration of this. And it says you should do like this, but what we really will get for each of these, because we're using lines, what we'll get, we'll say for each line that we have in here, we can do something. What we want to do for each line is we actually just want to print out the line. So we put that code here. And the next thing is we don't need, yeah, of course we need this first if we want to have that. But other than that, we don't need any of this other stuff here. So let me just, for now, just outcomment it like this. And now we only have one problem left, and that is that this can actually throw a Java IO exception. So we'll do as it suggests and actually surround it with a try-catch block like this. And this will also should also auto close and everything, so we shouldn't be afraid of that. So let's see if that works. Go up here, we have print file contents, and we would want to have the same as down here. And it looks the same. So this is actually a pretty easy way of doing it. So now that I've shown you this, which is pretty cool, I'll show you something that's even easier with java.nio. So there's actually other things built in. This is actually to do things line by line, but in this case, we're actually just wanting to read everything. So it's kind of weird. We're saying, I want all the lines. So like I'm saying, from this file here, I want all the lines, and for each of that line, I want to print it to the screen. But there is also other things in files. So let's say files, and we have a lot of cool. We can get it in different ways. So one of the things we can do is we can write and we can copy, create temporary files. We can delete. We can do a lot of stuff here. And we can even create readers and stuff like that. But one of the really cool things we can do is just use the method readString. And this will actually give us a string that actually represents the entirety of the file. So if we use the same as up here, like this path of file path, we have to wrap it like that. And this will just read the string directly. So if I wrap this into a system out print line, what I will get is actually the same thing. So this will just print the entire thing down here, no problems. So this was pretty easy, right? So this one up here is more like a generic one for reading each and every line, whereas this one is actually just for reading the entire thing. In this case, we want to read the entire thing, so I'm going to keep it like that and keep this in memory for something else. So let's just remove that and also remove all of this stuff. So now we kind of optimize this for doing reading the entire thing. So let's try to refactor the other things as well. So we also have one where we want to append to a file. So we want to append to the end. So let me show you that. This is also pretty easy when we are working with files from java.nio instead of this. Also, this is pretty easy though, but let's try to do it with files. So we're going to write again files, and this time what we're going to do is we're going to use the write. Okay, so I'm going to say files.write, and then I need to put the path, and again I need to say path of file path. So maybe instead of this path of file path, I should just go up here and then change this. So let's go private static string file string path equals something. I'll move that up here maybe. And down here I'll say path of file string path. So that I'll get, and this is of course not a what we would call a file path, but we would just want to call this a path like this. So now we have the file path like this. We don't need to use the path off anymore because it gets quite annoying. So we might as well just wrap it like that. Okay, and of course now this doesn't work. File string path. So let's try to change this. So I'm using files write, and what I need first is I need the file path. Of course it needs to know the path, and it also needs to know what it is I'm really trying to print. So I'll just add the text here. And the last thing is I'm going to say append. And right off the bat, it doesn't know append because it's a enum or a static keyword that we use for that. So we need to add that to our imports. So let me show you. So let's see if we can get any help here. No. Import static constant. Yes, from Java. This is hard to see. It says java.nio file. Yes, please. So that is it. So now I imported that. So the last problem I get, let's see, we have some kind of error here. Is probably just that we need to wrap this in something like a try catch block, because this will throw an IO exception. So let's do up here, say try. Put that into the try block. And then catch the IO exception here. Like that. Yeah. And I see I'm missing something weird here. Let me just look into that. Yeah, so let's see if we can get, so we see we need a path, and then we need something like, it's hard to see here. I think I remember now, we need some byte array here. So it's actually working not on text files, but on bytes. But it's really easy to get the bytes from a text. We'll just use we see it even suggests just to get the bytes raw like that. So we can change all of this into this really simple thing here, and let's check if it's also working. So this will append to the end. This is what this option here means, that it will actually append to the end. We could write 2 here. That would do kind of the same thing we can see in here. I don't know, that it's actually enum, that's ordinal to 2. So it's the same, but it's nice to see append here. We can also, to make it even more, we could copy all of this down here to make sure that we know that it's this kind of append. But I think I like to add the static import like this, so that we can use that. We can also use like star. We can see there are multiple options here. Append, create new, delete on close, read sparse, lots of stuff. So there are many different options of writing here. You can look those up. You can do a lot of things with this. So that's it. We refactored print, we refactored add to file. So now we should actually be able to add something to the file. So some NIO line that is added to the end of the file. We look now, there's nothing in the end. Let's print the contents after. So we'll do before and after. Okay, of course, this is because I changed file path into file string path. Try again. Same thing. Maybe I should have refactored before doing anything. Wow. Like that. Just keep going. So we look here, we get first, like the same, we read it, we do the operation, and we have the new IO line. So that was pretty easy. So we can just kind of use this files thing for everything. It's really an easy thing to use. Okay, so now for the more complex part, we need to use the add text to line thing. So which other options do we have? So we had the for each thing that we used earlier. I showed you earlier down here just to read the entire thing, where we could actually read it line by line by saying files, lines, and then the file path. And then we could do for each. And then for each element, we could say line. And then we could say, we could add that to whatever, like file input. If we had something like up here with the file input, we could say file input plus equals the line and then that part. And then I get into some problems here because I cannot use this variable here. So then I would need to make like final here for this to work, and then I get into other trouble. So we can't really do it like this for each. What we can do is we can do other stuff like filtering and stuff, but I don't want to do that. I want to show another way of doing it, which is pretty cool. Yeah, so we still want to use the files, but not the lines part, because that is mainly for doing operations per element on that one. So the one that we can use is, we saw before we had lines with a path, which will actually, in this case, we get something like a string back, but we can also get it back in other ways. So let me show you. So there's a method that we can use actually called, let's see, I think it's called read all lines, and we can actually see we'll get a list of strings back. So we need the file path, and this will actually give us back like a list of strings, like this list of string, all lines. And of course we need to import this, import class. Okay, and we need to wrap this in a try catch block, of course, for this to work, because this can throw an exception like this. So this way we can just read all the lines into memory as a list, and then we could actually just say all lines dot, and then we can add something at a specific index text, sorry, line number, and then we can add the text that we get. And that would actually effectively add that to the list of all lines. And then we can actually use the FileWriter again. So we'll just say files dot write, and then of course we'll use the file path, and then we need to put some bytes here. So we kind of need to get an array of bytes that we can just write. So if we look down at our method down here that we were using, let me see, we need to get the bytes for each text. So maybe we should use this method here. So let's try to do that. So we'll go through all of the lines. So we'll say for each string line in all lines, we can do something like this. And then we can say, now we want to say files write, and we put the file path. And then we need to put the bytes here, which is the line get bytes. And of course we need to append to the file like that. So now that this will actually write all of the lines to the file. Of course, we have another problem, and that is we need to kind of remove all of the stuff inside of the files. Otherwise, we'll just append to the end of the file. So what we can do is we can use the files up here to actually remove the contents of the file. So the way we can do that, so what can we actually do? Because we cannot just write in the middle of something that we are reading. So Now we've read all the lines and we've added that. So the problem here is that this will just append to the file we already have. So there's really no good way to kind of write in the middle of that. I can actually do something here, like I can do the count like I did down here. So we could do something like let's try to count how many lines that are in here, and then of course we need to remember to count it up for each line. And the other thing, let's try to say that if the count is the same as the line number, then we want to add that to the file. So we could do something, say if count lines equals line number, then we'll just write an extra line. So instead of line, we would do text get bytes like this. So that would mean that we would start out counting all the lines, and if we have the line number where we want to insert it, it will write it here. The problem is though that we are actually appending to the file, and there's actually no way we can go just in the middle of the file and start appending like that. For that, we need to use something called random access file, which I'll look at in a later video. So we need to do some kind of temporary structure to save this before actually writing it. And I think one of the ways we could do that is that we could try to create a temporary file. So so here we've read all of the lines, so let's try to create a temporary file. So we'll say files, and then we can use create temporary file, and with a prefix and a suffix. I think we could also just use temp file. I think I like that better. So I'll just use the create file, because we don't need all of this suffix and stuff. I think it's just easier to use. And then we'll just use the same path as before. So we'll just say file path, maybe file string path plus, and then temp, something like this. And because this is the raw string, we need to put that into a path of, just to make sure that we get this into the correct path. And then we want to use the create for that. And we get an error here. Let's see, create file. What do we need? Oh yeah, of course we don't need create when we're creating the file. Sorry about that. Okay, so let's keep going. So now we've created a file on this file path here. We can actually use that to for the contents of the file. So what I'm going to do is then we're going to kind of create the new file. So let's do like this. Instead of using the file path here, we're going to use the file path up here. So we better put that like in a path, temp file path, something like this. And then we can create a file on the temp file path. Sorry. So now we created a new file, and then we're going to use that in here instead, so that we are actually appending to the empty file. That means that after going through this, we will have a completely new file that holds everything. So let's see. So this is the read the old file, and this one will create new temp file, and we'll use the same directory and everything. Same name, except we'll have underscore temp behind it. This will add the line to add all lines, including new line to new file, or maybe call it temp file. So this is what we do here. So now we have two files. We have the temp file, which is the one we want, and we have the other one, the old one, which we don't want. The one on the file path is the old one. The one on the temp file path is the new one. So we kind of want to swap them and everything. So we can use files for that as well. So we'll use files, copy, and then we'll say the temp file path. We want to copy that to the file path, and we will use the standout copy option, and we'll use the one called replace existing, which will overwrite the file completely. So when this have finished, when we've copied the file, of course we need to delete the temporary file. So we'll say files, delete if exists, and we'll use the temp file path for that. So this will overwrite old file with temp file and delete temp. That's like that. So I don't know what you find easiest. It's kind of like the same thing we do here, except here we keep everything in memory until the last second, and then we append it to the file. So we kind of read the file into memory, then we write it line by line to the file, whereas we don't, because we have the buffer. But up here we are kind of using files, and so we create a new file. So we're certain that the entire temp file has been created before we start to overwrite the old one. So I don't know if there's any good or bad in this, or which one you prefer. This is maybe just a tiny bit smaller. I think this is also very nice and easy to read. So I'll remove the old one, and we'll be finished with this part here. So now we only need one thing. We need to check that all of this code that I've been showing you is actually working. This is going to be interesting. So we have this my file. I better copy this if it's getting deleted or something like that. So I'll remove this one, and we add new neo line right. We'll call that. We'll put it in line number 4, and we'll go in here and say 1, 2, 3, 4. So it should be somewhere after 3. Let's see. Let's play. And that was, let's see what's happened. Wow, I forgot something. You see, it kind of wrote it after each line. So something is definitely wrong here, right? It went from this to this. So there are no line breaks here, and it's all just, it has this weird new line in each and every line. So I definitely made a mistake here. I actually didn't expect this. This is kind of okay. So let's try to see what went wrong. So let's see. So first things first, let's see what's going on here. So first things first, if I run through this should be fine. It reads the lines, and it reads it. So the interesting thing that it actually reads it into a list. So that also means that, like before when we use the lines, it actually eats up all of the new line characters. So this is probably why it's in one line, and this is probably also why something weird is going on here with the. So fortunately, I saved the old one, so I'm just going to overwrite it with this. But yeah, let's try to look at it. So first off, kind of the line breaks are converted into a list structure. So before we get the bytes for the line, we would need to add something like a line break here. So let's do something like this, like we did. Yeah. And we also, of course, we need to do kind of the same thing up here with the extra line that we put in. Something like that. So let's see again. I'll just for the sake of it copy this and try to run it. Let's see down here what's going on. So it kind of like added it more than once. Let's just remove the 2 and then run it again. Let's see what's going on. So it kind of put 2 in there, right? Ah, okay, I can't do that. So if I go back to the previous version, it kind of put 2 of them. So what is going on? Why is it writing kind of like 2 of them? Yeah, so it's kind of appending. Let's just look into that for a second. So we're going into this. So now it's actually putting only in one place. That's a good thing, right? So let's look at it. We say count lines equals 0. We go through all of the lines. We check if the count lines equals the line number. And if that is true, we actually we append that to the file. Then we write another one with the line and that as an get bytes and append, and then we count lines up. So, what is fishy here? Yeah, so one thing that I didn't see, I had to just kind of look into things. So one thing that I didn't see before is I made a mistake because one of the things I'm saying here that I read the file, but actually in this line, I'm actually adding one line to the list of all lines. So actually I'm putting the new line that I want to add directly into the list here by using the index, and I forgot that. So I don't need to actually put it here in order for it to work, which makes it a bit simpler and nicer, I think. So if I go in here and just remove some of these lines here to make it easier to see, save that, and then I go up here and I put these in front of it to make it very easy to see, and I play. Now it works. It puts it in the correct line here and appends it just as it should. So this is one way to do it, and I think this is fine. If you want to do like reading and writing kind of at the same time, working in directly within files, you need the random access file to do that, and I'll show that later how we can use that. So I think all in all, java.nio kind of simplifies things a bit. Sorry. It simplifies things so that we can focus on working with files. And in this case here, you see I do this copying where I replace. I could have just overwritten the old file if I wanted to, but I chose to do it like this just for added safety. So I hope you learned something from this, and see you on the next video, which will be something on streams. maybe, or I think object serialization, I'll do that first.